roots and using rational expressions. So nth roots pretty much just means that we are taking any number of root of a particular number that we'd like, and this all depends on the index. So for nth roots, in this case, we have the square root of 16. That means the same thing as the second root of 16 to the first power. Obviously, the square root of 16 would just give us 4. So evaluating nth roots, we are going to see that this number out in front of our radicals are not necessarily going to be 2 or 3 like we are used to. So that number that is out in front of our radical, n here, is called the index. Okay? B is obviously just the exponent of x. Geez, I just forgot the x there. And then x is considered the base. So if the index is even, the radicand cannot be negative. All right, so let's look at a couple of examples here. So simplify the expression. So in number 1 here, I have the cube root of 16 or 64. So really, to simplify this, we want to simplify this by finding third powers because that is the inverse of our index of 3. So if you're struggling to think of what to the third power could factor out of 64, you can use something called prime factorization. So how that looks is you take 64 and you just take the square root of both of them. Or you take the square root of 64. So 64 is the same as saying 8 times 8. I can factor 8 as 4 and 2. Obviously, I can't factor 2 any further. I can factor 4 again as 2 and 2. And on the other side, my factors are going to look the exact same. Okay? So one thing that you guys will notice at this point is that on the left side of my tree, I have 3 2's. And on the right side of my factor tree, I have 3 2's as well. So these are the furthest factors of 64. But 2 times 2 times 2, which gives me 8, is just 2 cubed. So how I can split this 64 is I can take the cube root, 2 to the third power, which would be my yellow highlight, times 2 to the third power, which would be my green highlight. So now that I have 2 cubes, that will simplify nicely with my cube root, because all that happens is my exponents cancel. So this is the same as saying 2 times 2, which is just 4. All right, let's take a look at number 2 as well. So kind of the same process here. We're taking the 6th root of 64. So we're looking for a base to the 6th power to simplify. Obviously, we can use the same exact factor tree that we just used. And in this case, if we multiplied together 2 cubed and 2 cubed, we get 2 to the 6th power because we're adding our exponents. So to factor my 64, I could rewrite this as a 6th root of 2 to the 6th power. My 6's are going to cancel, leaving me with just 2. All right. So I'm going to skip the 3 on the right side to give us something to start class with. So let's go on to number 4. So number 4, I'm just taking the square root of 49, a to the 6th power, and I have plus and minus out in front. That's just going to carry down to my final answer. So plus or minus. So what I want to do is I want to break up my 49 and my a to the 6th power into second powers so that it cancels with my radical. So what to the second power gives me 49? That should be fairly obvious with 7 squared. And then let's just break up a to the 6th power into second powers. So if I have a to the second, I'm going to need another a to the second, which is going to give me a to the 4th, times another a to the second, which will give me a to the 6th. So if I was to simplify this, I would have plus or minus. All of my exponents are going to cancel because I'm taking the square root, which is just an index of 2. So that gives me 7 times a times a times a, which a times a times a can just simplify as a to the 3rd power. Okay? In an example like number 5 here, really the only difference from this one to number 4 is that we have a negative out in front. So really how I'd handle that would be to just factor out a negative 1. So I have the cube root of negative 1 times 8 times z to the 9th times q to the 6th. And now I want to factor my 8, z to the 9th, and q, so I have 3rd powers. So the cube root of negative 1, what to the 3rd power gives me 8, 2, and then break these down. Z to the 3rd times z to the 3rd times z to the 3rd. That would add up to give me z to the 9th, and q to the 3rd times q to the 3rd would give me q to the 6th power. Well, since we have an odd index, we can have a negative number. So the cube root of negative 1 is really just negative 1. The cube root of 2 cubed is just 2. And then we just take away all of our exponents. Okay, now I'd like to simplify this. Negative 1 times 2, negative 2. Z times z times z is z to the 3rd. Q times q is just q to the 2nd. Okay? So for number 7 here, this time we are also working with a negative, so let's factor that out right away. So I have the 4th root of negative 1 times, and then let's factor our 81. If you're unsure about 4th powers that would multiply into 81, let's factor. So I have 81, we can split that into 9 times 9, and we can split each of the 9s into 3s. So in this case, I have 3 times 3 times 3 times 3. That would be 3 to the 4th power. And there we go. And then let's just break our x to the 12th power into 3x to the 4th powers. Okay? From here, we have one problem. Remember, anytime you have a negative under an even index, so we have a negative 1 under an index of 4, you are unable to simplify this. So this would be a case that you would have no solution. Okay? This next one here, really, the first thing we need to take care of is to think about this negative. So this negative out in front is the same thing as saying negative 1. Try that again. Okay? So we can simplify this negative 1 because it's under an odd radical. And we are taking 2x plus 3y to the 3rd power. So let's first start, take the cube root of negative 1, which is just negative 1. And then if we take the cube root of 2x plus 3y to the 3rd power, our exponents are just going to cancel. So that's just going to give me 2x plus 3y. Okay, obviously I can simplify this one step further by distributing my negative 1. So that gives me negative 2x minus 3y. Okay, there is a little box to the bottom here. Relationships between exponents and index. If you haven't caught on by now, all the relationship in is just dividing the exponents by the index. Essentially what we're doing here, 3 divided by 3. All right, page number 2 here, we are looking at rational exponents. So for rational exponents, if we have a to the m over n power, so a to the fraction, the denominator is really our index, and the numerator is just our exponent. So in a case like number 3 here, or number 10 here, 36 is our base, that's our a value, 2 is going to act as our index, and 1 is going to act as our exponent. So it's the same as saying the square root of 36 to the first power. Or if we were using the other form, it'd be the square root of 36 all to the first power. It's really the same difference. The square root of 36, if we wanted to simplify it, we could say the square root of 6 squared, which ultimately just gives us 6. Okay? In a case like number 11, same process goes. 2 is going to be our index, 3 is going to be our exponent. So we can rewrite this as the square root of 36. And when you have an exponent that doesn't look like it would simplify nicely into your index, I would recommend using the second form, where we take this all to the third power. Because then we have the square root of 36, which we know is just 6, cubed, 6 cubed, 6 times 6 times 6, gives us 216. Okay, let's just take a look at one more example. Number 13 here, 3 is our index, 4 is our exponent. I'd recommend using the second form. So we have the cube root of 8, all raised to the fourth power. The cube root of 8 gives us 2, which to the fourth power, 2 times 2 is 8. 2 times 2 is 4, times 2 is 8, times 2 gives us 16. So the final section here, this is a bit of review. What does a negative exponent represent? Well, a negative exponent is a reciprocal. Okay, so whenever you see a negative exponent, I would flip it as a reciprocal right away. So 64 to the negative 1/3 is the same as saying 1 over 64 to the 1/3 power. Then we're going to simplify this exactly like we did up above. So that's the same as saying 1 over 3 is our index, so the cube root of 64 to the first power, so it doesn't really change anything. If we wanted to simplify this, you can look at the first factor tree we made, because we've got 2 to the third times 2 to the third, which ultimately will just simplify as 1/4, 1 over 2 times 2. Okay, in a more complex example, like 17, when you have a negative exponent outside of your fraction, just flip your entire fraction. So I can make this 27 over 8, all raised to the positive 2/3 power. Okay, 3 is going to be our index, 2 is our exponent. So I'd rewrite this as the cube root of 27 over 8, all of that squared. The cube root of 27 is just 9. Is just 3. The cube root of 8 is 2. I'll square it. Remember, when you square a fraction, you square both your numerator and your denominator. So this is going to give me 3 squared, which is 9, over 2 squared, which is 4. Okay? So hopefully I went through those examples in enough detail to give you guys an idea I would recommend that you guys try all of the examples that I skip on your own, yet in class we will make sure to go over them. All right, thanks for watching.